Hello everybody, welcome back to some more live streaming. Today we're going to be doing an implementation of Conway's Game of Life. If you've never heard of Conway's Game of Life, you'll like this. So, Game of Life is a cellular automaton. Shrewsbury says, hello, glad I could finally make it to one of these streams. Sorry I wasn't around for the other ones this week. Oh yeah, no problem, man. They're recorded, so you can always go check them out. I hope you enjoyed this one. We're going to talk about something really cool, which is this Game of Life. And it's basically a real simple set of rules that govern these cells. And so each square is a cell, and depending on how many cells are alive and dead around it, then it will either die. A cell will either die. Here, let me read you the rules first. Maybe it'll make a little more sense. So yeah, it takes place on a 2D grid, and it starts. There's 4 rules. It's actually very, very simple at its core. Oh. Hey, thank you, Shrewsbury. Oh yeah, I forgot to make it full screen. Should be better now. So, yeah, you probably couldn't see, but this is the... These are the things. Okay, so there's 4 rules. Any live cell with fewer than 2 live neighbors dies as if it's underpopulated. Any live cell with 2 or 3 alive neighbors stays alive and survives the next generation. Any cell that's surrounded by more than 3 live neighbors, it dies by overpopulation. And then a dead cell, a cell that has nothing in it, it becomes alive if there's exactly 3 neighbors around it, and that represents reproduction. And so with these 4 very, very simple rules, you get all kinds of really, really interesting things. And so one of the most well-known things to come out of this is called a glider. And a glider is this little thing you see here that looks like it's crawling along. Let me see if I can make it bigger. So basically, with those 4 rules, this little glider machine, this little glider thing, continuously goes in back and forth between these 2 little states, and it just goes on forever. So that's a glider. And there's all kinds of other really advanced things that people have found, like these little glider generators, and then these really large stable structures. So I want to show you well, let's see. Let's go back to the wiki page real quick. Linkso says hi, and Jeff Williams says what up. Hello all of you. So, let's see. I think they have a section here. Yeah, patterns. Okay. So here it says many different types of patterns occur in Game of Life. And so there is still life, basically a block that remains stable. It doesn't change unless there's outside interference. And there's the block, the beehive, the loaf, the boat, the tub. And with those 4 rules, it basically just stays in a continuously peaceful state. Then there's these ones that just go back and forth between 2 states. Like the blinker, I guess I haven't heard of some of these. The toad, the beacon, the pulsar, and the pentadecathlon. Okay. And then on the right they have the glider, which is probably the most well-known one. And that one happens a lot when you simulate the game. There's the lightweight spaceship, the middleweight spaceship, and the heavyweight spaceship. And these are structures that repeat and move. They move around, basically. And so I want to show you some really awesome videos. Yeah. Now I'm going to play this one, and I'm going to have to mute it after we sit through an ad. Okay, skipping ad now. Okay, no, it looks like YouTube's giving us another ad. We won't give them the satisfaction of watching. There we go. Okay, so watch this video puts together a few of like the really awesome compilations of patterns. So that's fine, go ahead. And we talked about the rules already. Yeah, every cell interacts with its 8 neighbors, which are the cells that are horizontally, vertically, and diagonally adjacent. At each step in time, each frame, each generation, each loop of the game loop. Yeah, and there are these rules that we already talked about. If there's too many neighbors, it dies by overpopulation. If there's too few neighbors, it dies of starvation. If it's just right, it survives. And if there's 3 cells alive around a dead one, then one comes back to life. Okay. So you can see the glider. This is just a couple gliders. I know it's really tiny probably. So there's like a glider generator that spits out these gliders, but it gets really awesome. So look at these. Now this is basically the same things on the other side, and the gliders just hit each other and they end up canceling out. And this is just a whole bunch of those put together, but people do a bunch of... Okay, yeah, so look at some of these crazy things. Look at these, like, I don't know, they look like butterflies almost. It, like, constructs a butterfly, and then it, like, spits it off. Yeah, I know this is probably really hard to see, because it's really tiny already on my screen, but you can kind of see it's supposed to be at a zoomed out level. But it's just to show you some of the incredibly complex things that people can build out of this incredibly simple rule set. And so we're going to do an implementation of this in Python. It probably won't support a giant screen size like this, but we're going to build a simple one. And so I'm just going to skip ahead. Yeah, look, they've even got ones that'll scroll across words. Ones that, yeah. So you can go watch some of these videos yourself and see some of the crazy stuff that's out there. But it's just really interesting in general. And there's one thing I do want to mention about the glider is Eric S. Raymond. Eric S. Raymond has a writing, yeah, so his website's really interesting. And he's got some really interesting write-ups, writings and blogs, so I think it may be under essays. And he's the one that wrote The Cathedral and the Bazaar, which is about open source software versus commercial software and the methodology of that, so that's actually a good read. And there's one here. There's one about the glider. Let's see, let me just go back and do a search for Eric S. Raymond glider. Yeah, so here, he has a post called The Glider, a universal hacker emblem. And you can see here, this is what the glider looks like in the cell state. Funnily enough, it kind of looks like a guy hunched over, working on a laptop out of his lap or something. So he's got a really interesting write-up about why he thinks this is a good emblem to represent hackers in general. So I recommend giving that a read too. And his website is catv.org. Yeah, catv.org. Okay, so back to what we're gonna do today. We're gonna do a game of life, and I have done these before. So let's see. Under projects, yeah, I have one called Nano Life that I did in Ruby. I did it in Ruby using a library called Gosu. Gosu is a game development library for Ruby, and it's actually really nice to use. It's really good if you don't have a very intense game. And so, yeah, maybe I can install that real quick and run it. It is up on the gem repository, the public Ruby gem. So hopefully I can get this to run, and let's see. You can see pretty much kind of what we're gonna do in Python. There we go. I think that's what I needed. I needed the live OpenAL headers to get the Gosu library to install. Now what is it complaining about? mpeg123. Hold on, I need to do sudo apt install, I don't know, mpeg123. Yeah, that. And I'll do mpeg123 dev. This should only take a second, but it'll be good to see. Okay, let's try the gem install, see if that works now. No? Okay, hold on. Ubuntu install mpeg123 header. What's the package? Lib mpeg123 dev. There we go. Sudo apt install lib mpeg123 dev. Okay. Let's give the gem install a run again. Okay, now it needs another one. Send file. Let's try live send file. And that was it. Alright. We may have to install one or two more dependencies real quick. Alright, it looks like it's installing. Now again, right up one more SDL. Okay, sudo apt install lib SDL. Lib SDL 2 or 1? Lib SDL 1? Hold on, Ubuntu install lib SDL. I'm probably going to need all these libraries anyway for Pygame, so it's a good thing that I install them now anyway. Lib SDL 1.2. Let's see, apt cache search lib SDL. I guess we can try lib SDL 2. Lib SDL. Okay, these are the two I want. Lib SDL 2 and lib SDL 2 dev. So yeah, we're going to be doing Pygame. A Pygame implementation of Game of Life. But I'm installing this one that I did in Ruby because I want to show you what we're working towards. Oh, yeah, here I have the whole list of everything I need right here. Well, at least some of it. Yeah, live sound file. Okay, let's try one more install. What I'm doing right here is installing. It's missing graphic libraries, sound libraries, those kind of libraries. That's what I was installing with all those apt installs. And those are probably going to be relevant. I'm definitely going to need SDL for Pygame, because Pygame is built on top of SDL. And so if you've never heard of Pygame, it's basically a game development library for Python. Okay. Oh, there's more. Fontconfig.h. Fontconfig Ubuntu. Let's see, it's going to be apt install lib fontconfig 1 dev. Sudo apt install Oh no. Ugly. Oh no, space. Okay. One more dependency down. Now the gem packages can't handle this for you, so the gem, the Ruby gem that I'm trying to install, it will install the Gosu dependency, but the Gosu dependency right now is trying to build, because it's built on SDL and C libraries and everything. It's trying to build the C extensions, and it can't find the C headers. So I'm knocking out those dependencies one by one, and it's okay because, again, I'm going to need all the same dependencies probably for this Pygame. So while that's going, we can go ahead and get PyCharm open, and we will start a new project with a new virtual environment. This is looking pretty good. It's going longer than it did before. And so the end goal, what we're going to do with the end goal by the end of the stream is have a working implementation of Game of Life written in Python and have it packaged up and pushed up to Pippy. The pippy.com, pippy.org, what is it? Okay, it's not pippy.com, I hope. Yeah, it's pippy.org. So this is when you do a pip install, this is where it's pulling from. And so we're going to package up the Game of Life that we write, and we're going to push it up to Pippy so that people can pip install it. Okay, so my gem is installed. Now I can actually run it. And so you can see this is basically what we're aiming for. And this is the Ruby implementation. And you can do a couple things. You can press S to start and stop the animation. And so you can see we've got a couple of the oscillators, a couple of the stables, and you see a couple gliders shooting around, and eventually it kind of stabilizes up. You left with basically stable ones, oscillators, and that's it. And you can press R and it'll randomize everything and kind of start it over. And that's basically all you can do. Start, stop, and randomize it. Oh yeah, you can actually interact with it. You can click on each one. And so you can like start it, stop it, and then like turn on individual ones. So if you want to set up the board in your own way. So we'll work on building something like that basically in Pygame. I'm sorry if you hear my dog crying, it's because we got a cat and she's trying to make friends with it. Alright, so now that we've kind of set the stage about what this Game of Life is, we're going to go ahead and start with a brand new project. Let's see, doesn't look like there's any kind of Pygame template in PyCharm, so we're just going to go pure Python, and we're going to call it Pygame of Life. I know, it's really creative, and we're going to do a new virtual environment with 3.6 inside of our project directory. So the tip of the day from PyCharm is the Control-Shift-J shortcut joins two lines into one and removes unnecessary spaces. Control-Shift-J, so J for join. Okay, let's go ahead and... So when you're making a pip package, you need to have a setup.py file, and generally you put your package in a folder. And so we're going to go ahead and create our Pygame of Life inside a folder called Pygame of Life. And, well, let's see. Yeah, it's kind of a long name, but that's okay. And basically we're going to want to import Pygame and start drawing. So we're going to have to install Pygame, and I'm pretty sure we can just do pip install Pygame. And we're using Python 3.6 in a virtual environment. Okay, we got Pygame installed. So let's go to a reference. Let's see, docs. And we'll go to tutorials, introduction, taste. Okay, I want let's see, I'm gonna copy this whole block, but we're not gonna use all of it. Okay, we're gonna want Pygame. Now, why does it say it can't find a reference to init? Mia, it's okay. Yeah, let's try and run that. That doesn't look quite right, since it says it can't find it. No, it worked. It worked okay. It's just PyCharm's having trouble finding that, and the only reason it failed here is because it's trying to load a GIF that doesn't exist. And I don't want to use any images anyway, so we can get rid of that. We're just going to draw all of our rectangles. And, okay, so here's the game loop, while 1. I guess I kind of prefer while true. That's just a personal thing. Okay. Pygame quit. Yeah, it's interesting. It can't find those. I wonder... Let's see. I'm gonna check real quick and see if there's any kind of Pygame plugin for JetBrains. Now where do we do? Oh, here we go. Plugins. And I guess we can just search for Pygame. Yeah, there's nothing there. That's fine. Okay, so we don't need anything to move either. Okay, yeah, we can basically fill the screen black and then blit. I guess this is where we want to put like our rectangles. Blit basically means draw to the screen. Put the memory into the video buffer, and then flip. That's kind of an SDL thing. You draw on the video memory that's not being displayed, and then you flip it, and then you draw on this. You draw the whole scene, and then you push the whole scene complete into the video memory. That's what flip does. So you basically blit to draw it and flip to push it into memory. Okay, so will this run? Okay, this runs. We get a blank window filled with black, and just to make sure, let's see, let's do red. I guess that's RGB, so red's gonna be RGB, and I'm guessing it's not 0 to 255, but it's 0 to 1 to do the colors. So normally you do hex 0 to 255, but I think this is going to be between 0 and 1. And just to confirm, let's try and turn the screen red. And that did not seem to help. So what if we do 255? Okay, let's stop and rerun it. Yeah, definitely more red. Way more red. And if we do 256, it'll probably... Error? Do nothing? Yeah. 255 is as high as you can go. So, sure. Let's do, how do you get cyan? I forget. RG and B? It's like, all G and B. 0255, 255. We'll do cyan equals 0255, 255. I think that's cyan. Yeah, we'll use that color to do our cell blocks, the alive cell color. Sure, we can just call it the alive color, and we'll call it the dead color. Basically, so if a cell is black, it's dead, there's nothing there, and if it's full of color, it's alive. Okay, we don't need speed. We will need size, and we're gonna say board size. Board size equals the width. And I'm making these big because they're going to be constants. And we'll do, what, 640 by 480? We'll at least make it a little bigger. And this way we can customize all this stuff up at the top. Okay, so yeah, let's fix this. And we'll fill the screen with dead color first. And then anytime we need to draw, we're gonna do this blit and flip. So we'll run it again, just make sure it still runs. Okay, we're getting our base set and ready to go. So what else do we need to do? We should make it a class. So I'm gonna make a class called Life Game. I'm basically gonna put everything in it. I'm gonna create an init function, and then here I'm gonna create a run function. Okay, and then down here I'll do if name equals main. We'll do game equals a new life game, and then game.run, just like that. So the benefit of doing it like this is that we then have a class that can be reused, or people can extend it or do whatever they want with it without having to run the game. But if you invoke the file directly, then it'll just actually run the game. And also, this will let you do, if you do like Python-M to invoke a module, then what it'll invoke the main, the __ main. And so there's a couple ways to do it. You can actually put it right in the file, like this, and so this is called a module. The .py, the Python file, is a module, and if you created it as a folder, then you basically have created a package. So one thing we could do here, like with this package called Pygame of Life, the folder, you can actually create a file called main dunder __, the double underscore is called a dunder. It's dunder main dunder.py, and then you can basically put the exact same code in there and not do it in there at all. And then here's where you would say import Pygame of Life, or from here we'd say in this case, since that just contains the life game class, we can call it lifegame.py, and then we can say from Pygame of Life import lifegame. We should be able to do like that, and then when we install it, we can have a launch script, so then people can do, they could do like this. They can do, I'll make a readme, and I'll show you what the end goal is. Okay, so Conway, this is going to be the readme that we're going to push with our package. Oh, Mythic says hello. Hey Mythic, glad you could join again. And Lisic Serenity says, hi, just want to say thank you. Oh, thank you, and you're welcome. I learned a lot from you. Do you know YouTube channel Jinvale Coldwind? I do know Jinvale from John Hammond's Discord channel. Right, so John Hammond has a really nice YouTube channel. Yeah, he does a lot of CTF and security stuff. And he did a Go stream a little while back. And I joined his Discord. He's got a Discord server. And Jinvale is one of the people on his server, so I discovered their channel that way. I wasn't familiar with it before. So we've got Conway's Game of Life, and so installation. I want to be able to do pip install, and we can call it Pygame of Life. I know it's long, but install with pip. That's one option. And then install from source. Python setup.py install. And then there's going to be running. Section on running. Let me make this bigger. Okay, yeah, so we got a installation and then running. Run via launch script installed with pip package. And then so you can launch it just like that. Run as a Python module. So then you can do python-m Pygame of Life like that. Using inside of code. And then you say, well, let's do it like this. To import the class into your own code, you want to do import Pygame of Life, like that. From Pygame of Life, import life game. Okay, so that's how I want people to be able to use it, and that's how we should package it. You should be able to pip install it and run it just directly as a script, or invoke it as a module, or use it in your own code. It says life game is not callable. Now why is that? It should be. Oh, well, yeah, it's a new class. Let's see. I think I do need an init. Actually, I don't think you need the init anymore in Python 3, but it's good to have. And so basically the same kind of thing. If you have an init function and you were using it as a file, you could put all of your init stuff in. If you had a whole bunch of init, you could put it in the init file instead of inside the module, inside the class. Okay, so what is it complaining about here? I think maybe it's because it's not installed. So for now, let's actually leave the main file empty, and we'll just do it down here. So we'll do if dunder name equals dunder main. We gotta do two equal signs, and then we'll start up a game and run it. So we'll go ahead and right click and do run just to make sure it still works. Okay. So it all works. Now we need to basically start drawing stuff to the screen. So let's see. We need an example. Here we go. Draw simple shapes onto surface. There we go. Draw rectangle. That's what we need. Actually, it'd be interesting if we did circles. If we use circles instead of squares. Why not? I think that would look kind of cool, actually. We should try it. Okay, so Pygame draw a circle, draws a circle shape on the surface. The position argument is the center of the circle, and the radius is the size. Radius, okay. The width argument is the thickness to draw the outer edge. If width is 0, then the circle will be filled. Okay, so let's try... Let's try just setting the screen once before the game starts looping. We'll do Alt-Enter. No. Why can't I find it? Pygame.draw.circle. And our surface should be self.screen. And our color will be the alive color. And the position right now, we'll just call it... Ooh, I think it has to be a tuple. 50-50. Radius, we'll give it 5. and we want a width of 0 because we want it to get filled. And what it returns is a rectangle, so we'll call it the circle's rectangle. I just want to see what the value actually is. I want to print the type of the circle rect and print circle rect. And then I want to... I guess I don't need to blit because I think the draw does the blit, so we'll just flip it and then we'll just run it. So we'll see if this draws a circle. No, it errors. That's great, but we can fix it. Circle takes no keyword arguments. Are you sure? Are we talking about the same circle? Import pygame.draw. No module named draw. Did I get this wrong? No. Pygame.draw.circle. Let's see, what version? Pygame print version. I need to see what version I have. I guess I could look here. I go in my virtual environment to my lib, and you go into the site packages. So it looks like Pygame 194. I can actually look in here and see. So what I need is pygame.draw. So we can go look in Pygame. We're in Pygame, we need draw. I see it. I see draw. It looks like it's just pre-compiled. It's pre-compiled, and I think that's why it can't find it. Let's try from pygame.draw import circle. No, it can't find that either. I mean, it looks like it found it. Maybe it just doesn't like... We'll just leave it like that. Okay, yeah, it just doesn't like the keyword argument. Cool. So we're getting a circle drawn on the screen at the position we want. And that is perfect. So let's write a function called clear the screen. Clear screen. And we're just going to say now there was how did they do it in the example? Let me go back. Okay, introduction. There was something called fill screen. Yeah, screen.fill. That's what I wanted. Okay, so clear screen is basically just going to say screen.fill dead color, and it's going to be self.screen since it's a class property or class object or whatever. Okay, and then I'm not sure if we should flip it or not. I'm gonna say no. I'm just gonna clear the screen without flipping it. We'll control flipping it manually. Okay, so we need a clear screen. We need a update generation. And so basically, we're also gonna need to store the grid, the game grid, and that's basically going to be a two-dimensional array, a two-dimensional list of lists, and it's gonna have more than this, but we'll set this for now. And we're gonna need you need two grids actually. You need the active grid, and you need the game grid inactive. You need like one in the background and one in the foreground. And so that's going to be kind of the same thing. Okay, so update generation is going to inspect the current active generation and then update the inactive grid to store new next generation, and then swap out the active grid. And that's basically going to be it. So for now we'll put a pass in there. So while true, it's basically going to say, okay, it's going to capture the events, and we'll also want to say if event is key press of S, then halt loop. We'll say pause loop. Pause game. Then toggle game pause. So it'll start and stop the game basically. If event is key press R, then randomize grid. If event is key press of Q, then quit. That'll be our event handler. And then, okay, so at the very beginning we're gonna say self.clearScreen. This is the very beginning of the game. As soon as the game boots up and starts running, we're gonna clear the screen, and we're gonna have another one called def draw grid. Okay. And it's basically going to do all the circle drawing. And we can easily change it to a rectangle. Okay. Clear that. We don't need blit. We are going to need flip. Okay, so we're also going to need, yeah, draw grid. So in draw grid is where we're going to call the flip. That game guy says, why Python? Well, because I've already done it in Ruby and in Go, and I don't think Java is the most popular with my viewers. I think Python's way more popular, so I figured I'd do a Python version. And because Python's pretty awesome anyway, I say, why not Python? You tell me why I shouldn't use Python? Let's see. So I'm gonna rework how we're storing those two game grids, but that's okay for now. Okay, so we've got draw grid, and basically we'll handle the events first. And right here we'll have a function called self.handle events. We'll go ahead and add the method, and we'll just paste in the event handler logic. Now why is this? Oh. Okay, and then we've got run Pygame display flip, clear screen, flip. So we're going to start off by clearing the screen, and then while it's true, we're going to handle the events, and then update the generation, and then draw the grid, right? That's basically what we want to happen over and over again. Handle the events, update the generation, and draw the grid. That game guy says, I love Python, just never really used it for game stuff. Yeah, I don't use it for game stuff either, really. This is really my first foray with Pygame. I've done game development with Unity and Unreal Engine and Java and Ruby and C++ and QBasic. That was my first one. So I've done quite a bit of game development, but I don't usually go for Python either. Oh wait, I've done Panda 3D too. So I guess that's not true. I have used Panda 3D to do Python 3D game dev. And Panda 3D is actually a really awesome 3D library. It's the one that Disney created for their Pirates of the Caribbean game. And it's all written in C++, so there's basically a C++ library that you can use, but there's also a Python wrapper to the C++ stuff. And that's the same thing that Pygame does. Pygame wraps libsdl under the hood, so it's really using all the C libraries, and you're just using Python to execute those C functions under the hood. But Python's really good for everything. Honestly, the other day we did Android app development with Python, and we made a Bitcoin price checker with Kivy, with Python Kivy. And you can do game development, you can do GUI development, you can do server side, you can do web dev, you can data science, machine learning, you can do pretty much anything with Python. And if it's too slow, then just write a module in C++ or write a module in Go or even in Rust. Write the parts that need to be performance critical in a performance critical language and then just use them as modules in Python. Anyway, enough about enough of my little Python rant there. I love Python, honestly. It's a great beginner language, and it's a great professional language. It's just a great language to have in your arsenal. Okay, so we got our game loop down. So we've got run. I'm gonna move run all the way down to the bottom of our class, so it's a little more intuitive. We've got initialize, which is basically going to create the screen, initialize Pygame, create, well here we'll say initialize grids. We'll just say init grids. Init grids, we'll say self.init grids. And then there's where we'll set up the grids in the beginning. So that'll be self.gameGrid, self.gameGrid. So I think I'm gonna do like this. I'm actually gonna put both of them inside of a list together. Hold on, I don't want to get too complicated there yet. That game guy says, I pretty much exclusively use it for Blender and Django. I really like Django too. I have a couple streams doing Django's, and I've built several apps with it. Blender is a really great tool. Blender is really good for 3D modeling if you need to do 3D printing, but Tinkercad's also good if you need to do 3D modeling for 3D printing. You can really easily, it's like the SketchUp of 3D modeling. So that's good for 3D printing if you need to do it. I've done some Blender. I want to show you something I made in Blender. It's Sketchfab NanoDano. Now, I made this in Blender. I painted all of the textures. I modeled it, and I painted all the textures in Blender. Not the background, but just the staff. It took me weeks of Googling how to digital paint wood texture and how to digital paint metal and stuff, and none of those tutorials helped. I basically just had to look really close at textures and but yeah, I did this in Blender. All of it. I did the modeling and the texturing and everything. But this is like the only 3D modeling and art I've ever done, and I'm incredibly proud of it. Okay, so back to our game here. We're getting pretty close to done, honestly. So we've got a lot of our structure lined up. Jeff Williams says, watching these streams have got me really interested in Python. If you're not already interested in Python, Jeff Williams, what are you interested in? I'm just curious. Do you program in something else? Do you program at all? Okay, so we've got, let's review where we are. I kind of lost my place. We've got init grids, ClearScreen, update generation, draw grid, handle events, and then our main game loop. So, you know, we can actually do the screen. We'll go ahead and do the screen clear up in the init, and then we'll leave the run for just the game loop. And the game loop is just going to loop over and over and over forever and it's just going to handle events like keyboard events and quit events. It's going to process the generation, and then it's going to draw the grid. Now, what we might need is time checking. We might need to actually make sure that it doesn't loop too fast. So we might need to check the time delta. And okay, so I need to sort out the grid and the drawing of the grid. Okay, so I'm gonna go with init grid, and I'm gonna start off by initializing it with all zeros. So I guess we're gonna do, okay, we're gonna do a cell size. If we've got 640 by 480 and we want a cell to be, I don't know, we'll call it 10 pixels wide. Let's actually have a cell size. We'll make a cell, actually if it's 10 we'll make it, it's going to be a radius of 5 but a diameter of 10. Okay, so we're going to say number of columns is going to be the width. Yeah, hold on. Columns is, yeah, the width divided by the cell size. That's how many columns we'll have. And the number of rows is going to be the height divided by the cell size. So if they're 10 pixels each, we'll probably get 64 by 48 cells. Not huge, but we can play with these numbers later. Linkso says, what low-level programming language would you recommend to start with? Out of, okay, you listed a few. You listed C, C++, C#, Go, Rust. If you're not familiar with any of those, it depends what your goal is. If you just need to write fast apps, go with Go. If you need like hardcore memory manipulation to do reverse engineering and stuff, I'd say go with Rust. You're gonna need to know C and C++ eventually anyway, but they're hard first languages, honestly. Go's is a good first language. Much better than C or C++ if you've never done any programming. Computers with Nikita says A. A is a good letter, I agree. Okay, so we've got a number of columns, number of rows, and so we basically need to create a grid. So we're going to say for I in range of numcalls. We'll do C. For C in range of numcalls, we're going to fill it. Let's see, for each row, new row equals this. How do I want to do this? What's the easiest way to create a 2D Python array with zeros? What's a default list? I think it's a default list. Oh no, default list is a separate, it's a third-party thing. Yeah, let's see if there's a quick way to initialize. Oh yeah. Wait. Yeah, this looks nice. That looks actually really, really slick. So, okay, let's break this down. It's basically, this is going to be, it depends how you want to do this. We'll say, numcalls. So in here, we're going to initialize it with a 0, and we're going to do it times the number of rows. And then that's each one of those rows is going to go and create there. So we'll say grids equals Okay, so my grids is actually going to be a tuple of 2. There's going to be an active one and an inactive one. And we'll say self.active grid equals 0. I'm not convinced this is the best way, but we'll just keep switching between 0 and 1. And actually, I'm curious, if we do a tuple is supposed to be immutable. Does that mean that I can't change the root list pointer object? Or is it saying even the contents inside I'll never be able to change? Because technically it's still the same list. I guess we'll find out. I'm curious how that works. Will it let me modify the list inside the tuple? And we can go ahead and fix code formatting. Okay. So init grids. Okay, we got the grids now. Let's go ahead and say print grids 0. Okay, let's run it and make sure it still runs. Down there, cannot multiply sequence by non-int type of float. Oh, is there not width? These should all be. Does it end up giving me a float? Yeah, that worked better. Now, we'll see how fast it runs, because Python's not known for being very fast, and we're dealing with large arrays, and these aren't like straight up arrays, they're like linked list objects. But it runs plenty fast in Ruby, so Ruby I think is a little slower than Python. Okay, so we're getting there. We've got number, we've got our grid. So yeah, we'll say, we'll go ahead and print out some debug information for ourselves. Columns, and it's a number printed with rows. And that's a number. And we want to pass it the num calls, num rows. I want to see how many. 64 by 48? Yeah. So that was looking good. Okay. So now that we have a grid, actually we need to we want to, we're gonna need the randomize function. And so we're gonna say for calls in self.grids active grid for row in self.grids self.activeGrid, and we'll say set self.grids self.activeGrid to a random value of 0 to 1 rand.choice. I think will let us just do something like that. What is it complaining about? Oh yeah, it doesn't let me, so I'm gonna just do a list. Okay, yeah, random choice 0, 1. Oh wait, we gotta do call row. Stop. And now we'll do so yeah, under init grid we'll create it, and we'll call randomize right here, and then print it out. And what we should see out in the list integers must be integers or slices, not a list. Hold on a second. I think I need that. No. What line is it? 34? Yeah, it's okay, hold on. Let's do this. Let's say self.grids active grid. Well, now what I'm not sure about in Python is if I assign this, will it just be a reference? Yeah, I'm not going to risk it. I'll just go with, okay, so I need four call in the grid, so I'm getting the active grid from the grids. Yeah, it should be like that. I'm almost positive it should be like this. Is it on the next line now? No, same line. For index call, I think that's what I have to do. Too many values? Yeah, so that's going to be dot iter items. No, is that iter items Python? How do you do it on a list? Well, I guess if I want to do that, I'd say for I guess I know how many rows there are. So for C in range of num calls, self.numCalls, self.numRows. Let's do this. Right click, refactor, rename, self.numCalls. What? What do you mean it's not valid? Yeah, it is. I don't know why PyCharm is being weird there. I just want to prefix all these with self so that they are class properties, so that they have a better scope. Because I need to re-access them later. Okay, for C in range of num calls, for R in range self.numRows. And then we'll say set at the grid of the column and row random choice 1 1. Now if we run it, okay, now it doesn't crash, and we actually get a randomized grid, and that's what we wanted. We just wanted the ability to randomize it, so we can initialize it, and we can also say now I want to make one called set grid to 0, like 0 out the grid. But now I'm thinking, let's do this. Let's say, instead of calling this randomized grid, let's call it set grid. Okay, we're going to call it set grid. And we're going to pass it a value with the default of none. And so here we'll say if value is none, then if value is none, cell value equals random.choice, and we'll do 0, 1. And then else well, let's see. I want to either take, if it's none, then we'll do random, else we'll just say cell value equals value, and then we'll just set it to whatever the value of cell value is. This way we have one function where if we want to zero the grid out, we can just call it with set grid 0, and that'll turn everything off. Or if we wanted to call set grid, and then this would be random. And so with this. All alive, all dead. So that's how we can use this set grid function. And it really should go inside a doc block. Okay. Okay, so now it'll randomize or set it all off, depending on what we want. So I'm going to stop it, rerun it, make sure it still works. Looks like we got a random grid down at the bottom. Okay, so we've got a grid randomized. Oh, you know what? We only set the active grid. Yeah, that's right. Well, we'll find out. Okay, so we've got draw grid. So basically we're going to have to say for same thing here. So for every cell we have, we want to do the circle. We want to draw a circle, and the position is going to be X is going to be the column times the cell size plus an offset of the radius. So that's kind of ugly, but that's the math, I believe, that we're going to need. And so the Y is going to be row times cell size plus an offset of half of the radius. And the radius is going to be cell size divided by 2. And 0 is going to be fill. We want it to fill. That's good. So let's run it. No, we got an error. Integer expected got float. Okay. Let's just cast it all to an int when it's all said and done. And rerun it. Oh, it's still... Where is it saying it got... Oh. Here. I'm going to do Control-Alt-L. This needs some reformatting. Okay. Try it again, and there we go. Now we've got the grid drawing, and it looks kind of weird because they're all circles, and they're not really the best looking circles because they're so small. But it looks like we got it going pretty good. So let's try this. In update generation, let's just try self.setGrid to randomized. And then we draw the grid. Okay, so this should just randomize it. No, wait a second. I think we're gonna have to clear the screen every time. Okay, so when we draw the grid, we're gonna clear the screen, draw the grid, and then flip. Let's see. Update generation and draw grid. Is it just happening way too fast? Or am I drawing the wrong grid? Oh yeah, no, I need to actually... So, the color is going to need to be either the alive color or the dead color. So it's going to be if this, then color equals alive color. Else color equals dead color. So we're going to say if self.grid of the active grid in column row equals 1. Will be explicit, otherwise if it's 0, I guess we'll just do like that. Try it out. Needs a colon. Hit play. And crash. No object named grid. It's game grid. Right? Game grids. It's called self.grids. There it is. Self.grids. Oh yeah, look at that. It's interesting that it's happening in lines like that. So I wonder if I have a bug. Let's add some sleep. So in our run, after every one, we'll do a time.sleep. Yeah, it's drawing the whole row the same color. So that's a bug. It shouldn't be doing that. So let's go back to our draw grid. For column and num-column, for row and rows. If self grid's active grid, column row is 1. Okay. Now wait a second. I think something's off here. Okay. So they're spread apart evenly, which is fine, but why is it always doing one row, the whole color, across the whole row? So we're doing set grid random. Maybe I'm setting the grid wrong. For column and rows. Yeah, so this looks okay to me. I'm not seeing anything jump out to me as where this is happening. So what I'm actually going to do is maybe set some breakpoints. And I'm going to do it in the set grid. Okay, so we'll debug. Okay, and now it's stopped there, so I want to basically step through it. And I want to look at this grid as it happens. So there should be a step through, step over, yeah, step over, that's F8, so we'll do F8. And we'll do it one line at a time. And we'll just kind of see. Okay, so there, boom, it just updated. Oh, okay. It just updated everything. It just updated the first element for every row there. Yeah, look at that. It's setting the whole row. So it's definitely in this loop is where the problem's happening. And so we've got now this is, let's see if we do step over. If value is none and value is currently none, so that should set it to a random choice, and that's happening. Okay, so yeah, the cell value is getting set to the random choice, and then it's going here and it's setting. Self grid, active grid, column row. But why is it setting all of them? This is where, boom, it just sets. It sets every row. Or every column or whatever. Why is it doing that? What am I missing here? For range in the number of rows. Yeah, so we're still on column 0, row 8. If value's none, it's still none. Okay, it's getting a random choice. That's fine. But it's like it's taking that random choice and it's keeping it for the entirety of the rest of that whole loop. When it should, like right here, should only set 1. You know, maybe it's the random. Maybe it's because it's doing it so fast. It's not rotating the number. So yeah, I'm gonna do an int, rand int, and I think that'll give me between 0 and 1. So let me see if that is it. It's just a bad random number generator. What does it want? A and B. Oh, it wants a to and a from. And it's doing the same thing. Let's see, let's pull up a different playlist. Maybe that's it. Okay, so this is... It's confusing me a little bit. I think I need to take a break and grab some water. I'm gonna give it maybe another minute. Why is it setting... I'm gonna try something. I'm gonna duplicate this. Wait. Duplicate commented out, and I'm going to modify it. So I want to actually make it random every single time, regardless of what I pass in. Now, just to make sure I'm not crazy, I'm going to flip these around, and yeah, it should break. Okay. Somebody's got to see where I'm messing up here. Handle events, draw generate. Yeah, I mean, it's definitely here. We're watching it set in the debugger. So if we look in here, we can see the grids and watch. We'll watch it as I step over it. It should only update one. It should only update one cell at a time. But it's updating. Oh, you know what? I bet it has to do with the way that these lists were created. I bet it's actually... I bet it's like actually creating a reference to the same one. I'm gonna try something else here in init grids. I'm gonna do self.grids equals. It's a list, and we're gonna make two. We're gonna say self.grids.append, and that's going to be a grid, grid 1. Grid 2, we're gonna have two grids. Okay. So grid 1 equals a list itself. And then for C in numcalls in range of no columns. Then we're going to do grid1.append, and we're going to append a row. And a row is going to be a new list. This will give us so I'm gonna do this the really, really long and terrible way, just to make sure that we're actually getting the things I want. For R in range self.numRows. This isn't the best. This isn't the best coding practices, kids. And row.append a 0. Hold on, this I'm starting to really confuse myself here. For the column number, in the range of number columns, we're going to create a row. No, we're going to do it like this. The column. No, this is absolutely terrible. Now, what's really confusing me is the fact that these all seem to be like linked to each other. Now, can I modify one of them? Set value, like if I set this one to 99. Oh, it didn't really like me doing that, did it? Let's try set value 999. Yeah, it didn't like that for sure. Okay. Two-dimensional array Python. This really is the trickiest part of the whole game of life, honestly. So yeah, they're just using a bunch of nested for loops. Yeah, another but similar way to create an empty list. Create an empty list and then append a new element to it each time. Yeah, so we're gonna do columns is an empty list, and for column in range self the num columns, we want to append now let me I'm going to reverse the way I think about this. For row number in range number of rows, and then we're going to say row dot append list of columns, and list of columns is going to be, should we try that again, times num columns. Okay, we'll add a breakpoint here. And then we'll check it. So what we want to see is we've got our grid there. Okay, that's fine. I'm going to say grid self.grids 0 equals the rows, which is the same thing as the grid. Okay, I'm going to stop it, and then I'm going to change the breakpoint to go back down here where we're setting it. Okay, no, I don't want rows now, I want self.grids. No, wait a second, I didn't want the breakpoint there anymore. Keep going. Wait, what happened to it? Oh, index out of range? Okay, that's fine, let's see. Okay, so because I swapped this, I'm just gonna swap that and swap these. And then I need to swap these too. Okay, let me try and debug again. No, index out of range. We'll say grids.append. Oh, there we go. Look at that. That is beautiful. That looks so much better. So it was something about the way we were creating the lists with the nested multiplication. This is much more so. It looks like I still need to fix one of these width height things is a little broken. Yeah, so it's down here. I think maybe it's these two I need to swap. Let me try that. No. Hold on. One of these it looks like I didn't. There we go. Yeah. That is freaking amazing. Now all it's doing right now is randomizing the grid and sleeping every second. So all we need to do to get this kind of finalized and fixed up is say instead of let's see, so in update generation all I'm doing is saying randomize the grid. So I want to not do that and I want to actually update the grid accordingly. So this is the big to do, and that's like that's like the last big piece we need to hook up, period. So I'm going to take a quick break. I'm going to get some water. I'm going to stretch my back, give my eyes a rest. I recommend, if you guys have been sitting around, you should go give your back a break, go do some stretch, go pet your dogs, and I'll be back in about 5 minutes. I'm going to put on a little music, and I will be right back. Alright, I'm back. Okay. So where were we? We were just admiring how awesome this Pygame Game of Life is going to be. So where we are right now is we have a grid. We have the grid being drawn every frame. And we have a function that's basically randomizing the grid every frame. So let's take out this sleep and tell it to run without the sleep. Yeah, so that's way too fast. So let's slow this down and we'll say basically we want to cap the frame rate. Cap frame rate at 60 FPS. Mythic says, today I'll probably stay with you for longer. Well, that's cool. So we're not too far away from being done. I basically need to wrap up the logic to update the grid properly. We need to cap the frame rate and maybe add a couple key log events. So if you press S, it'll pause, and R will randomize, and maybe C will clear it, stuff like that. And then we're going to package it up as a pip package, and then we're going to push it up and call it a night. So we need to cap the frame rate, and so basically if the time since the last frame draw is less than 1/60th of a second, sleep for remaining time. That's how we'll cap out the frame rate. So to do that, we'll have to get the number of milliseconds. Python get time in milliseconds. Let's see what Stack Overflow has to say. Millis int round time.time times 1,000. Is that right? Microsecond. Yeah, no, that's better. Date time microsecond. Okay, let's try that. Datetime.now.microsecond. So, where were we? It's in the update. Where are we capping the frame rates? Oh, down here. We'll do it in the main game loop. So cap frame rate at 60. We'll say datetime.now dot. What was it? Microseconds. And we'll do import datetime. Hold on, did it not find it? Okay, so we'll store it. Now equals this. And then at the end we're going to say self.last update completed is now. If now... Oh, you can do a time delta. Hold on, it looks like I got the wrong import. So down here we'll do import datetime.datetime. That did it. So if now we'll say if time between now, yeah, how do we get the time delta? Python time delta datetime.time delta. Okay, let's look up time delta example. These are the things that the date functions are notorious for being kind of confusing. So I don't think anybody will blame you if you have to look up the reference every time. So no, I just want oh, this website. I'm out of here. That website's terrible. Python time delta from journal dev. Let's see. Yeah, this looks better. So now I want to be able to hold on. Yeah, okay, so I can give it microseconds, milliseconds. Okay, basically I want to do something like this. If now okay, hold on. We've got now and then the self last updated complete. So now minus self.complete. That's going to be time since last update. Let's try this. Let's start that up. Self.lastUpdate complete equals datetime.now.microsecond. We'll give it an initial value. Okay, go. Okay, run it. Okay, so the microsecond. Oh no, that's time since last update in microseconds. So 8,000 microseconds is basically 8 milliseconds. Okay. So that's how many microseconds. And what I want to know is how many microseconds is in 1/60th of a second. So that's going to be 1/60th of a second times 1,000, a million. Microseconds. That's going to be the max, or we'll just call it the microseconds between updates. Okay, so that's how many we want to see. And we actually really only need to calculate that once. We can probably put that way up at the top. And then we want to say if the microseconds between updates, I guess we'll do if time since last update is less than microseconds between updates. And then we want to sleep for the remainder. So is there a microsecond sleep Python? Usleep? Yeah. Is there a usleep? Oh. Looks like you can just pass it. Yeah, you divide it by a million. Times a million. And the reason we're putting the dot zeros is so we get floating point answers. And then we'll say time.sleep for microseconds between updates minus time. And we actually want, this is in microseconds, So how many seconds is that? That's 1 divided by a million times that many seconds? It's that many seconds, right? So intuitive. Okay. And then we update. Okay, I think that'll do it. Okay, let's run it. Oh. Oh. It just like it takes, yeah, something's weird's happening. 1,000. 1,000. Yeah, it's doing something weird every... It's not quite doing what I wanted it to do. So actually, let's see Pygame frame limit. Let's see if they have a way to, they recommend doing this. Times in Pygame are represented in milliseconds. Most platforms have a limited time resolution of around 10 milliseconds. This resolution in milliseconds is given by timer resolution constant. Get ticks. Get the time in milliseconds returns the number of milliseconds since Pygame init was called. Okay, so that's actually what I want to use instead of all that. So let's actually comment that out for a little bit, and we're going to replace this with self.last update completed at self.get. Well, let's do the get ticks pygame.time.get ticks. Last date update completed. Okay, we'll say now is then, and we'll say if now minus last update completed is greater than, and we can keep this, but we'll say, since this is milliseconds, we're only going to do 1,000. So 1/60th. This is actually going to be milliseconds now. Milliseconds between updates. So if now minus last updated time is greater than milliseconds between updates, we're going to say pygame dot, what is it, time.wait. Time.wait for the delta. So let's just we'll just do the math twice. Is it quicker to do the math twice or to create a new variable and do it once? I think it's quicker just to do the math twice. Okay, so we'll wait for the delta. No, is this right? We want what we want is the milliseconds between updates minus the time delta. I think that's the number we want. And then we'll set last updated to now. Try? Okay, let's try capping it at something like 20 frames a second. That does look slower. No. That doesn't really look slower, does it? This would be one. This should cap it at 1 second, and it's not, so... Hold on. While true... We'll go ahead and do print now. Yeah, my math right here must be off, so... The milliseconds between updates... So we want 1,000 of those, that's going to be a second. So this is going to be... How many milliseconds since init was run? Minus that, so we expect that to be like, I don't know, 100 milliseconds. Okay, I think we want it to be less than here. Delay requires one integer argument. Let's try that. 1/1000. Okay, I think we're much closer now. I almost got it. Now the sleep. I think the sleep is what I have messed up now. So we'll say time to sleep. And then let's calculate this, make sure we got it right. So the milliseconds between updates is going to be the maximum time we want. So it's going to be that minus the time that we've already spent. And the time we've already spent is now minus the last update. And so we'll print time to sleep. Let's do this. We'll say time to sleep is that, and then we'll say if time to sleep is greater than 0, okay, so let's try this. If we say we'll get the amount of time it needs to sleep, and then if it does have any time that it needs to sleep, we'll say okay, go ahead and sleep for that time to sleep. But I think this is going to need to be something like that. No, that number is way too big. Wait, that's milliseconds. 500 milliseconds would be half a second? No, that's... something seems weird, so print now. Let's see, now... Okay. And then time to sleep is almost 1,000,000. So hold on a second. Let's break this down. So this is going to be time between time since last update is now minus that, and that's going to be milliseconds since last update. And so we're just going to make sure we've got this right. Milliseconds since the last update. And the time to sleep is going to be so milliseconds between updates. I'm going to call it desired milliseconds between updates. So we're going to have desired milliseconds between updates minus milliseconds since last update. And if there we go. Wait, greater than 0. Let's see. Hold on, so what's the difference between time.wait and time.sleep? Or delay. There's a wait and a delay. It is slightly less accurate than delay. This function will use processor rather... well... we'll try delay, I guess, then. It wants an integer. Okay, We'll give you an integer, that's okay. Okay, so now we got it running, and let's see. So now, continuously updates as we expect. The time delta is really, really small. It's only like 9 milliseconds between. Okay, so let's say, I need some more debug information here. It's getting late, I'm getting tired, so I'm having some brain fatigue, and I need to make this as easy on myself as possible. Desired milliseconds between updates. And then time to sleep. Okay, let's try this. Yeah, desired milliseconds between updates. Yeah, 1,000, because I told it I want to cap it at max frame rate. Max FPS. So I'll put that up at the top, max FPS. In this case, I just want 1, because I want to see it work slowly. So that's right. Oh. Okay. And then, so it happens fast, and so it should be sleeping for almost a second, but it's not. So the math is alright, it's just not actually sleeping. So the time to sleep divided by 1,000, so maybe it's the time to sleep that's messed up. Delay actually takes milliseconds, so I need to put time to sleep in there. Boom, there we go. Now it's sleeping too long? Hold on a second. Stop. Almost got it. Almost got it now. Okay, so that math is okay. That math is okay. That math is okay. This is where it gets weird. Time to sleep. And let's see. Delay wants milliseconds. We'll pause for a given number of milliseconds. So time to sleep is right. Oh no no no! Whoa, that number is way off. Hold on. Yeah, time to sleep should be divided by 1,000. 110,000 milliseconds is 110 seconds. Stop, restart, and now it breaks, that's okay. It wants an integer. Okay, give it an integer. Why is it getting such a high number now? Because is it okay? Time milliseconds since last update. Stop. Restart. Oh yeah, why is it giving me a negative number? Now minus self last updated complete. Oh, because the very first time around I need to set that. Okay, boom. Actually, I'm going to set it to 0 since it says it's time elapsed since pi init, and we'll assume it's 0. So there we go. That is so much better. Now if we set the max FPS up to, we'll set it to 30. No, that's too fast. 15? 15's still kind of fast. Say 8. That's okay. That looks good. Okay, so now that we got the frame rate capped, that was a really important step because we don't want it to go too fast. But it's still just doing everything randomly. So the last step is to get rid of all the randomness. Okay, so we'll call this one self.capFrameRate. And we're just going to put all of that code inside there. Like that. And this we will set as a class value up in the init function. So back up in the init function we will set... Oh, Mythic, you say you're going to be going? Alright, well, it was good having you. Thanks, have a good night. Okay, so in the init function, now we're setting up the desired frame rates and all this. Okay. So now our game loop has one extra step. It's handling the events, updating the generation, drawing the grid, and then capping the frame rate, which is basically just waiting if it needs to. Okay. There we go. That looks really good. Now I'm going to clean up a couple of these debug statements I have. Okay. So that's grid 1. We're going to say def create grid. And let's do like this. We're going to create 2 grids. Because we need an active grid and an inactive grid. And we'll set the active grid in here. Okay, this looks a lot cleaner, and it actually works. And we can set these, yeah, we can set these here too. Okay. So now we're looking pretty good. We've got a good initialization, a good grid initialization to give us our 2 grids, and something broke. That's okay, we'll fix it. None type is not subscriptable. Now, let's see. Grids append, grids append. It's having a problem inside set grid. Okay, so this is not... Let's try this. Now these should be good objects. If not, well, let's figure out why. Oh, because I'm not returning them. That's why. Yeah, okay. That should work a lot better now. You have to return stuff from the function. Okay, excellent. So still looking good after some refactoring. Okay. Okay, I can clean out a lot of this stuff. And actually I can add this back in. Okay. Just cleaning up some of the stuff I did earlier for testing. Let's make sure it still works. Yep, still looking good. Okay, so we're at like one of the last steps we need to do here. And one of the last things we need to do is get our update generation thing going. Self.activeGrid, so we'll say if self.activeGrid is 0, self.activeGrid equals 1, else self.activeGrid equals 0. So we're basically just going to swap the active grid between the two lists. And we don't want set grid because that basically randomizes it. But instead we want to start with grid 0, or the active grid, and then go through each cell. I guess it doesn't really matter which way you iterate through it, but we'll do it like this, and we'll say self.grids, self.activeGrid, and the row column. So that's the active cell, or like the specific cell. And so we're gonna have to check its neighbors. This is the, let's see, we'll have a function called check cell neighbors. And we're gonna pass it the row index and the call index. Okay. And what we're gonna pass in is the R and the C. We're actually gonna ask it to do it. Called check cell neighbors. Okay. And basically it's going to return whether it needs to die or not. Next gen state equals this, and this is either going to return 0, else return 1. If alive next generation, return 1, else do that. And this is where we implement the 4 rules of the too populated, underpopulated, death, birth, current cell. Okay. And then we're basically going to set the inactive grid. So self.grids I guess we can do self.activeGrid +1 and then do the remainder 2. So if it's 0, then the inactive grid is going to be 1. So 0 plus 1, remainder 2 is going to be 1. If it's already 1, then the off grid is going to be 0. So if we add 1 to it, we'll get 2. 2 remainder 2 is 0. So that'll automatically pick the off grid. So we'll say set the inactive grid future cell state equals next gen state, and we do that for each one, and then we just swap the active grid. And I guess we could do the same thing here. We can just say active grid equals inactive grid self dot inactive grid will just be a function that returns that value. Then we don't have to keep swapping the inactive grid. Well, let's see. Yeah, just like that. We'll just set it to the inactive grid. That should work. I'm going to put these right next to each other, though. Okay. Why doesn't it like the C here? We'll figure this out in a second. Now, why is this unexpected argument? No, it's not. What if I use it? Check cell neighbors. Oh, it needs self. Self needs to be the first thing. There we go. Okay. Almost there, so now we've got to update the generation. This is going to inspect current generation state, prepare next generation. Okay. So this is where we're going to basically set up all the logic to check cell neighbors. So we're going to need to get the number of alive cells surrounding current cell. So we're going to need to know the neighbor to the left, to the top, to the bottom, to the right, and the diagonal ones. And then we basically just say if num alive neighbors is 3 exactly, then alive next well, if it is dead, hold on a second, I gotta look up the rules again. I just gotta think about it. We'll start with the first one. So if num alive neighbors is greater than 4, then it's dead. Return 0. Then we say else elif num alive neighbors is less than 3, then it dies due to starvation, right? So this is underpopulation, overpopulation. There's 4 rules. There is come back to life. So there is if num alive neighbors is 3. Well, hold on. There's two cases there. So if oh no, that deleted. Okay, self dot grids dot active grid row column. Okay. So if If the cell is dead and the number of live neighbors is exactly 3, then it comes to life. This is row index, column index. Come to life. Okay. I'm gonna do these in this order then. Come to life if it's dead and number of live neighbors is 3. If it's greater than 4, overpopulation. If it's less than 3, it dies. And then I guess it's otherwise it lives. And so the only other case would be it would basically be if number of live neighbors equals 3 or 4. If it's 3 or 4 and it's alive, then it stays alive. What is it not like here? Invalid target for variable notation. Okay, now I gotta calculate number of alive neighbors equals count live neighbors. I guess we'll just do it right here. So we'll say check all 8 neighbors, add up alive counts. So I guess we'll just start with the top left, top right, blah blah blah. So we'll say row index -1, call index -1, and then row index -1 but the same column, and then that one, and then we'll say on the same row, same thing, back, middle, left. And then here we'll actually say, actually we don't need, that's the cell itself. And then the last one is going to be row index +1. So all 3 on the row below it. Yeah. And we're going to try each one. I guess we would do it like this. It's going to be self.grids, the active grid, .get, and in case it does fail, we'll return an empty list there. And return 0. So I think this is how we're going to do it. That way it won't error out if it doesn't exist. So I'm going to duplicate that. And yeah, so I'm going to do the same kind of thing. Well, I guess we should make sure it works. We can try it out in just a second. So row, and here it's going to be +1 -1, 1 0 +1, And then we're gonna check, yeah, the row below, the same row, and then the row above. Okay, so we're gonna say num alive neighbors equals 0, and then plus equals that, plus equals that, here, there, and that one. Now let's go ahead and print num alive neighbors. Okay, let's try it out. And error, that's okay. Oh, list has no get. List has no get. Is there another one? Python list get. Do I have to try each one? You can always get an empty subset list. Okay, let me go back a little bit. Let me go back to where I had the array indexes listed. I thought the get would be safer, but I guess a list doesn't actually have the get property. It's only the dictionaries. So let's do this. We'll have a function called, we'll just make our own. We'll call it get row column. And then we'll say try to, let's see, cell value equals self.grids, self.activeGrid, row column. Yeah. Except, and just say cell value equals 0 and return cell value. Okay, so we'll say get cell, and here we'll just say get cell, and we'll do each one of these. We're gonna have to do it 3, 2, and 3 more times. So I'm going to do this multiple cursors, hold down Alt and click, and you get multiple cursors. No, can I undo that one? Yeah, there we go. Okay, so what I'm going to do is clean up these brackets. Yeah, I guess the multi-cursor has its limitations. I'm basically rephrasing these so they can be parameters to the function. And then I'm going to pass them in like this. Just one at a time. We need to get all 8 neighbor values. And I'm missing 1. Okay. And here we'll say, yeah, we can get rid of all these. And here we'll say num alive neighbors equals 0. And then we'll add on each one of these. And then we check, we'll go ahead and print it out just to make sure it looks like it's working okay. 2, 1, 2, 0, 1, 2, 4. Okay, it looks cool. Int object not subscriptable. It's okay, what do we need here? Line 69 needs to be fixed. And what's the problem here? Self grids, active grid, RC. Int. Why does it have an int? I didn't tell you to have an int. Hold on. Return. Okay, so check cell neighbors. Next state. Next gen state. Now hold on a second. Why does it... Hold on, let me put a breakpoint here. Let's do a debug. And let's see, grids. Oh. There's one grid, but there's no second grid. Okay, so the second grid is not getting initialized properly. Print self.grids, and let's set a breakpoint there. Now it should be initializing two separate grids. Okay, it is. Now apparently the... Oh, I know what's happening. When we're updating the active grid... Where are we doing that? Update active grid. Yeah. No, yeah, all we're setting is... Okay, so let's see. Self.grids. Where are we making any changes? Oh, here we go. This is where I should actually be setting the specific cell to the next generation state. And I was setting the entire grid, which is supposed to be a big two-dimensional list. I was just setting that to 1. Okay, so now it's complaining about int and none type. Get cell should... Now why, even when it has an exception, it should default to cell value equals 0. And we'll say that's like on the edge. So if you have one on the edge, it doesn't have a whole 8 neighbors to check. Okay, yeah, so look, it ran through a whole bunch of them, and it errored out like way at the end. Get cell unsupported types, int and none type. It's this one in particular, so but that's weird because get cell no matter what. Now why is, yeah, so this is turning out to be a none? No way. None of the values should ever be none in the cell value. Cell value equals 0, just to be triple sure. Okay, so it's happening in check cell neighbors, get cell. And get cell is doing nothing but checking the active grid and getting the value. We'll say print couldn't get cell value. Row this and call this. Okay, So now when it has that problem, we should see... Yeah, so anytime it's in row 48 or in column 64, it can't pull it. And that's totally normal. Okay, but then it's... Couldn't get cell value 4864. Oh... Do I need to do minus, like, -1? No, hold on. I think I have, like, an off by 1 error happening somewhere. Oh. Couldn't get, that's fine. Now it's erroring out like right at the end. Because it's trying to reach out of bounds. But I know it's reaching out of bounds. I'm handling that. Let's see. Where exactly is... Now, why would get cell ever return... Why would it ever return none? What? Yeah, well, see... If... No matter what... Like, we'll set it to 0. We'll try to update it. And if we can't... Yeah, what in the world? Where... How could it ever... I mean, let's try putting it there. Self. You know, maybe that's why. I don't think that would be why, but just to be sure, we'll pull it out of being one of those inner functions. Yeah, it did make a difference. Alive neighbors. Okay. Okay. Check cell neighbors. Now, where's the other print statement coming from? I don't need that one. Print cell value. Try it again. Cell value 0. It seems to be going through all of them okay until it gets to the very, very end of the whole thing. So maybe I actually need to do num rows -1 or num rows I got a none. Yeah, how did it get a none there? How in the world? How in the world does this end up being none? I mean, I'm setting it to 0. And then I'm trying this, so the whole grid must be getting messed up again. The whole grid must be getting set off. The whole grid must actually be returning none. So yeah, we'll step through it. I guess it's gonna get to like all the way to the end. Let's see, how do I say keep running? Okay. Resume program. Resume program. Resume. Okay, yeah, look, now there's some none values in there. There's a few nuns just scattered. Oh. Oh, I know what's happening. I think. The first grid never actually gets populated with zeros? No. I don't think that's it. Hold on, let me check and see, make sure there's no nuns in them from the get-go. Yeah, no, that's nice and clean. Nice and clean. Okay, resume. Now there's a bunch of nuns, but they only happen in the second one. They only happen in the second grid. And it happens a lot in the second grid. Okay, so I think what I need to do is when I'm updating the grid, I need to have an else and say return 0. That's, I think, where it ends up returning none. That's where the nuns are coming from. Yeah, there we go. Something still... it's a little wonky because it's treating the neighbors. It's treating the edge of the screen weird. So I think what I'll have to do is let it wrap around. And so the top will just continue up to the top and the left will kind of loop around to the right. But this little guy, this is not normal. He shouldn't be doing this. So I think I have my rules wrong. I'm gonna pull up the rules real quick for Conway's Game of Life. So yeah, any live cell with fewer than 2 neighbors, any live cell with 2 or 3 neighbors lives. That's where I think I messed up. So it's not 3 or 4, it's 2 or 3. Fewer than 4 dies. Hold on. Fewer than 2 neighbors dies. Overpopulation is if more than 3 live. So if it's got more than 3 live, any dead cell with exactly 3 live neighbors comes to life. Okay, so let's break this into 2 parts. We're gonna say if the cell is alive, we're gonna check. Hey, good night, Jeff Williams. Sorry we didn't get it done a little sooner. I got hung up on some of this, but we're almost done. We're like super, super close. Okay, so David says, "Hi Dan, glad to see you in your Guardians of the Galaxy costume." And I totally agree. This character, the first thing it makes me think of is Rocket from Guardians of the Galaxy. And I think that's a good movie. Okay, so we're almost done here. We're getting really, really close. So we're going to do this, and then we're going to say, else it's dead, and the only time it comes back from the dead... No, wait a second. So if it's dead and it has 3 alive neighbors, then we're going to return 1. Come to life. And just to be explicit, even though this is the only other case it ever should be, we're just gonna be real explicit about the condition. So if it's alive, then we're gonna check these conditions. Overpopulation, underpopulation, and then just stay alive. Okay. Now, let's run it again with these rules. And let's see if that covers all the cases yet. No, it looks like we may have missed out on a case. Any live cell with fewer than 2 neighbors dies. Any live cell... Okay, any live cell with fewer than 2. So, a live cell with fewer than 2 dies. Any live cell with 2 or 3, let's see, lives. Any alive one with more than 3 dies by overpopulation. Any dead cell with exactly 3 neighbors lives as if by reproduction. So if it's dead and it's surrounded by exactly 3, come to life. Interesting. The rules don't seem to cover all of the cases. So these rules are still leaving a case where something unexpected's happening. I guess at that point we'll just let it remain in the same state. We'll just return it as it is. There we go. That's looking much better. Now it's still a little wonky around the edges, but we are seeing the stable structures we expect. We're seeing the oscillators that we expect. We're seeing the beehive and the square and the cross, and we're seeing some gliders. There's a glider right there. Now the edge is a little weird, so we're gonna have to work that out. So what I'm gonna do here is say left neighbor equals, well, let's see. If it errors out, how do we get it to wrap around? What's the best way to get it to wrap around? I guess we can do it up here. So if I'm trying to think the best way to do that. Now, what am I doing with, what did I do in the other one? Does it wrap around to the other side? No? It just ignores it? It just doesn't go anywhere. Okay. Now, how should I be handling the edge cases? Now, I've already implemented this, but it's been so long now I'm wondering, game of life handle edge of grid. What do we need to do? Border rules. I wonder if that's actually on the Wikipedia page. We'll say Conway's game of life. Wikipedia. We'll say edge. Yeah, a more sophisticated trick is to consider the left and right edges of the field to be stitched together, and top and bottom also, yielding a toroidal array. The result is that active areas that move across the edge reappear on the opposite edge. Yeah, that's what I want to do, but I'm thinking about the best way to do it. This is gonna be ugly, but I'm gonna do it this way. Actually, I'm gonna pull up my code here and see what I did before. So I've got one probably called the same thing. Update. Yeah, I've got one called update. Oh. Oh, I think I know what I'm doing different. The inactive grid needs to be set to all zeros. Okay. And we'll say grid equals 0. Okay, so now I can set the inactive grid to 0 to clear it out. I think that's what I need to do. So right before I update the generation, I need to call self.setGrid 0 in inactive grid. Let me try that. Yeah, that works a lot better. That's what I needed to do. So basically, what I'm doing is there's two grids that represent the game board, and while one is active, that's the current generation, and while we're examining the current generation to determine what the next generation looks like, we are building the next generation in the grid that's not active, but the old state is still there. So the old state has to be wiped out before you build the next generation. So that's what I was forgetting to do. Okay, so now we can just start cleaning up the code. So I'm gonna get rid of all these print statements, and these are all the rules for life and death. Look at that. 10 lines of code. 10 lines of code determines the entire fate of this organism. And I kind of like the circles. Okay, so there's still some debug print statements I can get rid of. And then we're going to actually look at cleaning it up, packaging it as a Pipy application, and documenting it, and all that good stuff. I'm going to slow it down just a tiny bit more. 12. It's a little hard to see with the circles. That's fine though, we'll leave it like that. And so we can easily watch, we can make the size bigger. We can make the screen bigger and we won't have to change anything. It'll just magically add more cells because it's all doing it dynamically. So as long as it's like a nice multiple of 10, it should be fine. Awesome. So we can adjust the board as needed. And actually, I'll probably move all these to be class variables that can actually be set in the constructor if you actually want to override it. So let's see. To do, take all of these as constructor arguments. That way we can change any of that stuff that we want to when we create it. Okay, what else? To do, add doc strings, package as pip package, add keybinds. Okay, so we actually do want to do, let's see. Okay, I'll move those in a second. Now, get rid of that. Can get rid of that. Okay. Now I wonder if I can delete that and it'll... No. Yeah, I'll leave that. Leave that else, the final else statement there. The final default return condition. Update generation. Okay. So here... So yeah, we want to check the key if event dot type. Okay, now let's do Pygame check for key press. All right, let's get some chiptune going again. Here we go. Python key get pressed. Now let's see, Pygame key event. Pygame.keydown. So I guess we want to say if event type equals Pygame.keydown. We'll say key pressed. Print event. Okay, yeah, there we go. Key presses are working. So we'll say if key event dot no, that looks like a dictionary. So is it like that? Let's see. No, not like that. Let's try event dot Unicode. Yeah, there we go. Key pressed. Okay, cool. If key down, then we say if event Unicode equals S, self-paused, if self-paused equals false, else self-paused equals true. So we're going to toggle a pause event, and in the initializer we'll just go ahead and set paused to false. And then if it's true, we will just not update the game. Right, so we'll just say if not paused, if not self.paused. I guess we could just do it like this instead. We'll do, if it's paused, we'll just return. No, we don't want it to return, we want it to continue. We just want it to end the loop, shortcut the loop, and keep going, but we still want to handle the events. So now, S, alright, S will start and stop it. You can see I press S and it pauses it. Boom, awesome. Okay, so now we're handling the S key press. And we'll say print toggling pause. Okay, then we say, well, else if the key code is R, then let's say randomizing the board, randomizing the grid, and we'll say self.active, well, let's do this, self.setGrid, and we set it to random. And so we'll do this. We'll say self.activeGrid equals 0. We'll just reset the grids. Grid equals 0. Set the grid to random, and then set the inactive grid to zeros. Randomize and set to 0. So now if we press R, it will randomize, it'll just randomize and kind of restart the game. R, S, so we got start, stop, randomize. Okay. And let's see, does draw grid do the blit? It does. Okay, so let's when you press R, even if it's paused, we'll draw the grid. Okay, so if I do random, if I pause it then do random, it'll still fill it up. Okay, cool. And let's do one last check, and we'll say if the event is Q, if the event is Q, then we'll just say exiting, and sys.exit, or I guess we can just say self.gameover equals true, and then we'll do the same thing here. We'll just say if self.gameover, then return. We're done. We're completely done, and we'll leave the loop forever. Okay. And then up at the very top, we'll just need to set game over to false. Self.gameover equals false. Boom. Okay, so now we've got start, stop, randomize, quit. Awesome. We have it done and working. Now the last step is to document it with doc strings, create a readme, package it for pip, and push it up to Pippi. And those steps shouldn't take too long. So I'm gonna look it up. I'm gonna, let's see, to do add doc strings, to do write readme. Okay, we added the keybinds. To do take these as constructor parameters, and to do push to Pippi. Okay, so these are the things that I'm gonna do next. And I'm gonna use, well, which one should we do first? So, a lot of you are probably familiar with Markdown, but you may not be familiar with restructured text. Now, this is my preferred writing format. It's not that different from Markdown, but it's very powerful. Now, I have almost a whole chapter of a book written on it that I might pull up in a second, but what I'm going to do is go take a break real quick. I'm going to grab some more water and stretch my back, and then I'm going to take care of these last to-dos. So while you guys are waiting, I do encourage you to take a break too, stretch your back, check out restructured text and Pygame, and I'll be right back. Alright. Hello everybody, I'm back. So, last thing I mentioned, I was talking about restructured text. I'm going to close all this up. Okay. So there's a last couple things I wanted to do before we wrap up. I wanted to add some documentation and package it up as a Pippy thing. So these are going to be nice and easy, just kind of clean up tasks. This is kind of the fun part to me, honestly. So first, we're actually going to, let's take care of this to do first. So here we'll say width, screen width, and we'll give them defaults. 800. That way you don't have to pass any of these, but if you want to customize it, you can. Screen height equals 600. Cell size equals 10. Alive color equals. Now, I've never seen. Is this not a? Is it a tuple without the parentheses? Is that all that is? I guess we'll find out. Dead color equals 000. And max FPS equals 10. Okay. So now I'm going to delete all of those. I'm going to... Now I'm going to have to fix all of these. Okay, so this... Oh, I can't rename it? Okay, so that's going actually to be screen width, comma, screen height. Okay, and max FPS. We only need that one time. The screen width we actually do need to save, so we'll say self.screenWidth equals screen width. And same thing with the screen height. Okay. And the width is going to be the same thing, self.screenWidth divided by self.cellSize. And we'll save that one too. Self.cellSize equals cell size. Self.alive color equals alive color. Self.dead color equals dead color. Okay, that's gonna be, it's gonna be better. Self.screen height divided by self.cell size. Okay. Why is that all squiggly? Oh, it needs to be in the doc string. That's what it's complaining about. I'm not doing the docs yet. Right now I'm just kind of going through and making sure all these look good. Okay, so alive color is actually going to be self.alive color. And here, self.dead color. And here it's going to be self.cell size. And there's a few of these, so here, 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 here. Self.dead color. Okay, no more red squigglies. It looks like we're all good. I'm gonna go ahead and run it. Okay, looks like I did break something. I gotta add a plus there. Okay, looks like we're back in business. Start, stop, randomize, randomize, quit. Awesome. Game is looking good. Okay. Okay, this all looks good. Now I'm going to go back and I can get rid of that to-do item and add doc strings. I'll go ahead and do that now with PyCharm. It makes it really easy. You just open up the 3 quotes and then boom, it automatically fills it out for you. And by the way, Alexander Vinogradov says, "What's up?" Welcome back, Alex. Alex is our JavaScript enthusiast. But soon he's going to be a Python enthusiast. I mean, after you see this, how can you not be? Okay, so we don't really need much of a description for this. We're going to just basically say initialize grid, set default game state, initialize screen, yada yada yada. And cell size is going to be the diameter of circles. And screen width should be, well, I guess that's fine. Alive color, RGB tuple, e.g. 255, 255, 255, and same thing for the dead color. 4 cells. Max FPS is frame rate cap to limit game speed. Okay, screen width and height. I don't think those need to even. We'll just say window, game window width. Game window height. Okay, cool. That one looks typo. Initialize. Okay. Now we're done. We're done documenting that one. Init grids. This is going to be create the default active and inactive grid. Returns none. This is going to be generate an empty 2D grid. Create and stores. Okay, and this one here. What is this? Set a grid. Set an entire grid at once. Set to a single value or random 0, 1. Okay, grid is going to be index of grid for active, inactive, 0 or 1. Printer value to set the cell to 0 or 1. There's no return, so that one looks good. Draw grid, quote, quote, quote. It automatically fills it out for us. This is going to say, given the grid and cell states, draw the cells on the screen. Okay, clear screen. Fill whole screen with dead color. Okay, almost done doing the documentation. Then we can push it up to Pippi. So get cell. Okay, yeah, I want to change. This is going to be the row number. And this one's going to get refactored to the column number. Okay, get the alive, dead, 0, 1 state of a specific cell in active grid. 0 or 1 depending on cells, on state of cell. Defaults to 0, dead. Okay. We are almost done. Only got a couple more functions to document real quick. Check cell neighbors. Get the number of alive neighbor cells and determine the state of the cell for the next generation. Determine whether it lives, dies, survives, or is born. Okay. Row number of the cell to check. Column number of cell to check. Returns 0 or 1, depending on the next generation state of cell. We'll just say the state this cell should be in next generation 0 or 1. Okay, that looks good. This one's already commented, so we don't have to do anything. Add one here. We'll say simple helper function to get the index of the inactive grid. If active grid is 0, we'll return 1, and vice versa. Here we've got handle events. We're going to say handle any key presses, and we'll say S is start, stop, pause the game. Q is quit. R is randomize board, randomize the grid. Okay. And run is kick off the game and loop forever until quit state. Cap frame rate, if game is running too fast and updating frames too frequently, just wait to maintain stable frame rate. Okay. Launch a Game of Life. Okay. We are all done documenting it. This is one beautiful looking class now, isn't it? Alright, so we added the doc strings. Now let's add a readme. Okay, so yeah, we want this running controls. We'll say there are a couple keybinds available. We've got Q, quit, and S, toggle pause. We'll say start, stop, toggle pause, and R, randomize the grid. Okay, and it's always good to put maybe some contact information. Put your name, your email address. Ideally you have like a change log, but there's not really much here, so no change log yet. Conway's Game of Life, simple Pygame implementation of Conway's Game of Life. Okay, can we preview it? Okay, installing, running, using encode. That's good enough. It's good enough. Okay, so now we actually need to make our setup.py so that we can actually install it. I'm going to delete those. Okay, so what I'm going to use as a reference here, let's see, so I believe in the Python one I've got notes on creating a pip package. Yeah. So I'm actually going to use two resources. I'm going to use some code that I've already written and already packaged as a pip package as one of my references. And in fact, I'm going to start there. So yeah, all you have to do is Well, hold on. None of these are requirements, actually. It's just Pygame. Package data. There's actually no package data. Scripts. We'll call it Pygame of Life. Pygame of Life.bat. Packages. Pygame of Life. That's the directory that I created. And okay, we'll call it version 1.0. Give it a little description. Conway's Game of Life implemented with Pygame. And we'll call it Pygame of Life. Why not? Okay, so that looks good. The only thing we need here actually is the bin directory. And then we're going to create those two Pygame of Life. That's going to be a launch script. And then Pygame of Life.bat for Windows. So that you can launch it easily in Windows. And I'll show you what goes in that. So in the batch file, we'll go ahead and install the batch plugin. Give me 1 second, I'm gonna take a drink of water. Okay, so this batch script basically just calls the Python script, but you need the batch script in order to kick everything off because Windows is weird. So that should be okay. That should do it. Actually, one problem I've had with this is if you have a space, in your home user directory, you have a space, it'll break the Windows launcher. And so basically we want to say from Pygame of Life. And this is where we can basically pull out the main, if name equals main. Basically do the same thing. User bin env Python, launch a Game of Life, just like that. So now what we can do to test it out, we've got a virtual environment, so what we can do is python setup.py develop, and then it'll essentially make symlinks to our package with everything on our working directory. So we don't have to build it every time we want to test out the package changes. And so now I can just do Pygame of Life, and it should show up in my path. Okay, and it didn't. Okay, so I need to do an import. So I need to say from Pygame of Life import life game. That Pygame of Life. Okay, now that should make it happier. It says modules not callable. Hold on a second. Oh. So it's from Pygame of Life.lifeGame import life game class. Like that. Okay, and boom. We got it. We got our launcher working. Now let's try this. If we do python-m Pygame of Life. Now here it says there's no module named Pygame of Life __ main. And so what a module is a Python file. And that's all it is. So if we make a dunder main dunder.py, that's actually going to satisfy this module that it's looking for. And so I can take this and put that there. And then I think this will work better. So let me try this now. There we go. Okay. So let's see. Call main from Python. I'd like to sync because there's a little bit of duplication here in the main and this launcher. Well, if this is just a shell script, then can I just... No, hold on a second. I'm gonna leave it like that. That's fine. It's only 2 lines. Okay, so now we've got the launcher. Our main is working, so you can invoke it the way I showed you at the beginning. Or you can call it directly with the launcher script. Perfect. That lines up exactly with our README, so pip install or Python setup, then you can launch it this way or launch it this way. And if you want to import it, then you can do it like this. Okay. Technically, that's all you need. Just like that. That's really technically all you need. I'll even do that in the other one too. Boom. Just like that. Okay, so that's nice and clean. Nice and clean. And then we got our class that's nice and clean in this file. Okay, so we wrote the README. We packaged it as a pip package. And I'll show you if we do a pip list, we should see it installed. And we can see Pygame of Life 1.0.0. And it's actually a symlink is what it's telling us here. And okay, so the last step is to push this up to Pippy. So there's actually, okay, so to push it to Pippy, there's actually a couple steps. Setup.py, you do sdist. Yeah, so you type, instead of doing Python setup.py install or develop, you do sdist, which stands for source distribution. There's a bdist too. So you do source distribution, and then you have the pip package. Now with this package, you can run, you can just say, so it's in the distribution folder, you could say pip install py da 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 da. I don't know why autocomplete's complaining, but you would just install the tar.g like that. But I've already got it installed right now, so... Okay, that looks good. I've built the distribution, so the last thing I need to do is just push it up. Okay, and Twine is really the package that you want to use for that. Twine makes it really easy. Now where is it? Yeah, so... Here you go. Pip install Twine. Python setup.py sdist to build your source distribution, and then you just say Twine upload file. It's that easy. So now that we've built it, I'm going to say Twine upload dist / Pygame of Life 1.0.0, and you don't even have to register it or anything. It will automatically attempt to register the package if it doesn't already exist. So let me get my username here. My username here is DevDungeon, and my password, you know what, I'm hesitant to pass it in there because the PyCharm terminal is not always the best, so let's try this. Now let's try the Twine here. Okay, now I'm going to do Twine upload dist / and then the the zip file that it created. Then it's just going to ask me for my username, and I'm going to punch in my password. And then that's up. Dev Dungeon isn't allowed to upload there. Does that mean it already exists? Pippi Pygame of Life? Does somebody already have it? Oh, they do. Someone already has it. It's called Pygame of Life. Okay, so let's call it something else. We just have to rename our package since it's already taken. And this is where you name it, right here. None of the other names matter. Not the file, not the... not anything. But to be consistent, I am going to refactor. I'm going to try calling it NanoLife. And so I'm going to refactor. I'm going to call it NanoLife. That doesn't really change anything else. I'll just delete the distribution directory because we're going to rebuild it. And I'm going to rename these from Pygame of Life to NanoLife. Even though that's the same name of the Ruby one I made, that's okay. And so, just to make sure it's, let's see, pip uninstall Pygame of Life. And remove Pygame of Life egg. Okay, so now let's try Python setup.py develop. And just make sure we didn't break anything with, oh no. That's the Ruby one. Let me try gem uninstall NanoLife. I'm uninstalling the Ruby one because that is conflicting now. Clear. Now we run it. Python-m NanoLife. There we go. Okay, now we'll try pip uninstall NanoLife. Python setup.py develop. Now Python setup.py develop. NanoLife. The launcher's not working. Hold on a second. Oh, here, it didn't update these. The refactor didn't catch that launch script. So now it launches, and now we're all good. And now we have a name that should be free. I mean, I don't think anybody's taken that one, but I guess we'll find out. So we'll do Python setup.py, sdist. Interesting. It's some Z shell stuff going on there. So pip uninstall NanoLife. Python setup.py sdist to build our zip distributable. There it is, a beautiful zip file of our package. And now we'll do, I'll go back to my terminal and I'm going to say twine upload, and I'm going to upload that tar gz. And then I'm going to put in my password again. And it's done. It just uploaded it to my package. So let's check it out. Let's do a search on Pippi. And there it is. Oh, there's no description? Did I not put? No. There's a description right there. Oh, there's a long description, I think. Setup.py long description. Description. Yeah, there's one called long description. And I think what is good to do there is say long description equals README file contents. That's actually a really good thing to put in. So here we'll just say this function doesn't exist, so we'll do Alt-Enter, create function, README file contents, and what we're going to return is the file contents of the README. And so we'll say open with open, and we want to say current directory. Hold on, I gotta look up. So you can pull the current directory of the current file itself. So was it in here? No. Let's see. Python get file directory. So you've got the file. The file name is like that, and then you want os like .base dir of the file. I forget exactly how it goes. os.path.dir name of os.path. Yeah. This is how it should be. Import os. So you get the directory name of the full. You get the full path of the file, and then you just extract the directory name from the full path of the file, and the file being the setup.py. And the setup.py lives right next to the README file. So you say open the README file. Well, actually, what you want to do is we want to open that as README file. File contents equals README file.read. Okay, and actually, we want to open. It's going to be kind of ugly, so let's break it out into a separate line. README path is going to equal os.path.join of that plus readme.rst. Like that. Okay. And then here we'll say open README path. Okay, so now when we build it, when we build the distribution, it'll dump the whole README into the long description so that we actually have contents here on Pippi. And also what I want to do, since I'm going to push this up to GitHub, I'm going to make a GitHub repo and I'm going to put that link in the README as well. Nanolife Pi. So Pygame implementation of Conway's Game of Life. Nanolife package on 50. Okay, let's grab this URL. We'll say git init, git remote add origin there. Let's grab the HTTP URL and put that in the README. We'll put that down at the bottom. Source code available there. No. Let's see. So now I actually want to git ignore file. Yeah, I want to ignore everything in dist. I want to ignore star.egginfo. I want to ignore store.pyc, any pycache directories. I think that's it. So now if we do a git status, .idea, I want to ignore all those. Star.iml, git status, the virtual environment, I don't want to add that. Okay, git status, git add. This all. One thing I want to do too is roll the version number. Since we are making changes, we need to roll the version number, and we're not adding any new features, so we're not going to change the middle version number. We're not breaking any backwards changes, so we're not doing that, and it's only basically bug fixes. So 1.0.1 is a good version number to roll up to. And then we're going to say stable working commit that is pushed to Pippi. Oh, I need to update the README because it still has the other package name listed. So here we actually want to say pip install nanolife. And nanolife, python-m nanolife. From nanolife import. Okay. So that looks good. Commit fixing references from Pygame of life to nanolife. Git push. Yeah, let's do it. Git push. Set up stream origin master. Alright. It's now up on GitHub. Oh, you know, we should put as a screenshot, huh? That's what it could really use. Screenshot. Okay, let's take a screenshot, shall we? Screenshot. We'll see. Okay, so pip install nanolife. Nanolife. Oh, it didn't run. Let's see, I need to fix that one too. Now, why didn't... Maybe it's because I still have the other one. Pip install nanolife. Oh, it's still using the cached 1.0.0. Pip no cache. No, not remove cache. Yeah, dash dash no cacher. Dash dash no cacher. That's uninstall. That's fine. Okay. Well, shoot, I guess I haven't pushed 1.0.1 yet. Or even built it. So, okay, hold on. Pip uninstall one last time. And... Okay, screenshot or no screenshot? Let's try this. Run... main... Stop. Okay, yeah, we'll take a quick screenshot. Select area to grab. We'll say screenshot, save it in NanoDano, Pygame of life, screenshots, screenshot, okay. Now, Markdown, add screenshot. Oh, this isn't Markdown, is it? RST add image? Okay, so I'm just adding a screenshot. I think I'll do that like right here. Screenshot. Image. Screenshot slash screenshot.png. Is that it? No. We'll see if GitHub. We'll see if GitHub renders that image. Oh, do I need to do? Okay, so we'll try that. Let me roll up the version number again just to be sure. And we'll say git commit tweaking for package push. Okay, so the other thing I want to do is now I want to rebuild the distribution, so setup.py sdist. This. Okay. now we want to do a twine upload this nanolife 1.0.2. Push username dev dungeon and then my Pipy password. Okay, so now if we go back up here, we should see a much better... Yeah, there we go. So now we actually see the whole README. And we did that by just saying long description equals the README file contents. So now every time we push a package up to Pipy, the README here will be the same as the README that we push up to GitHub or whatever. And it's even got a link to the GitHub. So that's good. Oh, yeah, okay, so GitHub does render the restructured text image tag properly. So it is putting the screenshot. It's a little wide, but that's okay. We'll leave it in there. And I do actually, while I'm at the other site, I'll go ahead and put the other one here. So this way we've got a link to the GitHub code and a link to the Pipy package. Okay. So I think we're good. Let me try this now. We'll do pip install nanolife -- no cacher. This should force... No! It's still pulling 1.0.0. But, yeah, 1.0.2 should be the latest one. Okay, pip uninstall nanolife. Let me get out of that directory and try it again. No cacher. There we go. Now it downloaded 1.0.2, and let's launch it, and it works. Let's launch it the other way, python -m nanolife, and that works too. So we are good to go. Now I can do pip uninstall nanolife, and we can see that it shows up as 1.0.2. Okay, so let's go back into the project, git status. All I did was update the link. Okay, so I might as well 1.0.3. Okay, so all I did was add Pipy link to README, roll version, push it up to GitHub. Now I'm going to do python setup.py sdist, and then I'm just going to do a twine upload dist nanolife 103. And then I just need to pop in my credentials again. And you can actually set... So you can set up a file in your home directory called a .pyprc, and then you can tell it where the repositories are. And this is the default repository. And you can specify your username and password so that you don't have to enter it every time. This is also good if you have private repositories that you want to pull and push from. So now we go here, we should see 103, and we see that it's all good. So the screenshot breaks here because it doesn't understand the relative link. So I wonder if we gave it the GitHub image link, it'd be better. Yeah, as long as it stays in the same spot. I'll just leave it broken, it's okay. Not a huge deal that you don't get the screenshot on the Pipy one. I might try putting a base64 image and just like encoding it right in there. Or something else, I'm not sure. But this is good enough. So we did it. We did it, everybody. It only took about 4 hours from start to finish, but we got a nice game of life implemented. Start, stop, restart, quit, and it's all up on Pipy. well documented. Well, it's relatively well documented. We actually went through. Let me pull it open. We actually went through the whole class and made sure all of them had doc strings and all that good stuff. So I call that a win. We made a game from scratch, packaged it, pushed it up to Pippi. I think it's a decent project. So I hope you guys learned a little something about the whole workflow from start to beginning of a project and how to push something up to pip, and otherwise learned a trick or two. Let me just make sure. Yeah, we're all good here. Okay, so we're all done there. If you want to install it, go to github.com/devdungeon, and then it's called NanoLifePy there. But there you've got all the instructions in case you missed it, it came in late or anything. You can just go ahead and install it with pip install nanolife, and then run it like this using either of these, or run it from inside your own code. And there's a couple keyboard controls. So knock yourselves out, extend it, play with it. Maybe you want to change the circles to squares. Maybe you want to change the colors, change the board size, do whatever you want. But I hope you guys liked it. So as I sign off, I'm going to mention a couple things. Go to devdungeon.com, go to join me on Discord, and click this button in the right sidebar and come hang out on the Discord server. You can get my book, Security with Go, if you want to learn Go and InfoSec stuff. On the YouTube channel, make sure you subscribe to catch the daily live streams that have been going on. And go to the GitHub page, check it out, and I think that's it for now. So thanks everybody. If you have any suggestions, come post them on Discord, leave them as comments here, and tell me what you thought. Have a good night.